Okay, welcome back to part 2 of this lesson. So let's do one more of these types of questions together before you try the next two on your own. So again, let's try and create the mapping rule first. So again, for x, let's take a look inside here. We've got x plus 9. Okay, so my suggestion is, no matter how simple it seems, you always write out the flow chart of what happens inside the function here, what happens to x. So we go x and we do plus 9. And even though there's only one transformation here, we remind ourselves that in inverse, we go x and then minus 9 for the mapping rule. Okay, now as for the y part of the mapping rule, the y component, you'll see the function gets multiplied by negative 1 over 7, and you subtract 8, so you get negative 1 over 7y minus 8. Okay, which means now if you plug in 8, negative 21 inside this mapping rule, so 8 goes in for x, negative 21 goes in for y, so 8 minus 9 gives you negative 1, and negative 21 times negative 1 over 7 is positive 3, minus 8 is negative 5. Okay, now as for the transformations, again, whether you start with x or y does not matter as long as you are consistent within each variable. As long as you have the right order within each variable. So let's start with y. So the first thing that happens to y, again, look to your mapping rule for the order, is we multiply by negative 1 over 7. So that does actually two different transformations. So we have the 1 over 7, which gives you a vertical compression by a factor of 1 over 7, and that negative is a reflection of the x-axis. So do not say it's a vertical compression by a factor of negative 1 over 7, because the compression factor has to be positive, right? The negative gives you the reflection. So that's actually two separate transformations, and the order of these doesn't actually matter because they happen simultaneously. So even if you're with the reflection first here, that's okay. And then after that, it gets shifted down 8. Okay, in addition to it being shifted down 8, then you can look at the x value and it's shifted left 9. X minus 9, if you subtract from your x values, it's going to move it to the left. So we have down 8 and left 9. Okay, so hopefully it's starting to make a bit more sense after a couple of examples. There are two others here, part C and part D. I'd like you to try part C on your own. At the very least, try and create the mapping rule. Once you create the mapping rule, push play again. I'll show you how the mapping rule is done, then you can try the rest. Okay, but the first step is to make sure you get the mapping rule correct. So try that and push play and ready to go through it. Okay, so there's your check. So the mapping rule should be 2x plus 5 and then negative 2y plus 7. For a reminder of where that came from, let's start with the x. So again, look inside the function here for everything that's affecting the x variable. Make the flowchart. First thing that happens to x is a subtraction of 5, then a multiplication by a half. If you want to try and avoid fractions, then it might be easy to rewrite this instead as multiplication by half, try division by 2. Okay, and then for the inverse, instead of dividing by 2, we're going to multiply by 2. Reminder that we reverse the order and the operation. Okay, and then instead of subtracting 5, we're going to add 5. So x gets multiplied by 2 first, and then we add 5. Okay, as for y, you have negative 2 there, plus 7, so negative 2y plus 7. Okay, so with that in mind, try the rest. Try and find the image point over here of 8, negative 21, and try and listing your transformations down there below. Okay, so if you put 8, negative 21 inside the mapping rule for x and y, you should wind up with 2149. As to transformations, again, let's start with y in this case, doesn't actually matter. So with y gets multiplied by negative 2 first in the mapping rule, so that gives you two things. It gives you the vertical stretch by a factor of 2 and reflection of the x-axis. Then we have a plus 7, so that means sometime later on your transformations, the up 7 should happen. Again, you cannot write the up 7 before the vertical stretch and reflection because, according to the mapping rule, the multiplication by negative 2 happens first. Looking at x, the multiplication by 2 happens first, so that means the first thing for x that needs to be written is the horizontal stretch by a factor of 2, followed by the plus 5, which means we go right 5. Okay, so this next one I'd like you to try completely on your own. So try and do the mapping rule, image point transformations, and push play and ready to go through it all together. Okay, so take a second there and check your answer. Mapping rule for x. You see that it's negative 3x minus 12, so x times negative 3 and then minus 12 inside the function. So for your mapping rule, you take the inverse, x plus 12, and then divide by negative 3. So x plus 12 first before you divide by negative 3. For y, multiplying by 1/3 and subtract 18. Okay, which gives you an image point of negative 20 over 3 and negative 25 when you plug those values 8, negative 21 into the mapping rule. Okay, again for your transformations, look at your mapping rule. So if you start with y, we have y times 1 over 3, which is a vertical compression by a factor of 1 over 3. That needs to be written sometime before the down 18. Okay, for x, what's very important here is you see the first thing that happens to x is this plus 12, not the division by negative 3. So the x plus 12, the plus 12 tells you it's a shift to the right 12, and then you divide by negative 3, which gives you two different reflections, the reflection in the y-axis, and simultaneously the horizontal compression by a factor of 1 over 3. Okay, so what we've looked at here is going from a transformed equation to a mapping rule to transformations. Now let's try and go from a mapping rule back to the transformed function. Okay, so looking at this first one right here, again, f is any kind of generic function. We're going to be using a lot of just general f's right now. Again, note that f could be any function, right? Could be a square root, could be a parabola, we don't know, right? But we're going to work with general functions first before we start working with some of our parent functions here. So we know in our particular case here, we have our mapping rule. So to create our new equation, we have to look at what's happening to both the x and y components. Looking at what's happening to y, we know that the y value of the function gets multiplied by negative 3. So we're going to start with negative 3 here. And we know they have a vertical shift up 8, so somewhere at the end we're going to have plus 8. Okay, what we need to look at is what's happening inside, what's happening to x. So we have x divided by 4 minus 5. Remember that to go from the function to the mapping rule, we had to take the inverse. So to go the other way, mapping rule to function, we have to take the inverse of that. So looking at what happened to x here, it's x divided by 4 in the mapping rule, and then minus 5. So for the inverse, we go plus 5 first, and then multiply by 4. So inside my function here, I'm going to wind up with x plus 5, and then multiply it by 4. So again, negative 3f, bracket 4, bracket x plus 5, close brackets, and then plus 8. And then you can see we get the same thing there. And again, f can be any function, so let's say it turned out that the original function was f of x equals root x, and was a transformed square root function. Well, instead of f right here, what we'd have for a transformed function is the square root of 4 bracket x plus 5. Okay, it depends what the original function is. Let's just say it was, I don't know, let's say it was absolute value of x. Well, then what we'd have instead is absolute value of 4 bracket x plus 5. So it completely depends on what the original function was. Okay, with that in mind, like you now try B. So I'm giving you a different mapping rule. Try and create the equation of the transformed function. Okay, so there you have your answer in the purple rectangle there. 2f bracket 5x minus 7 bracket minus 10. Again, look at what's happening to x. We add 7 first, then divide by 5. So for our function, we're going to multiply by 5 and then subtract 7. So x times 5 minus 7. And for y, it's just 2 times y minus 10. There's another form written down here, which really the only difference between them is that the 5 is factored out here. So you have 5 bracket x minus 7 fifths. I don't care which form you write it in. In fact, this one's probably a little bit easier to read, the original one, the one in purple. But you might see some textbooks or some places online where they always factor out whatever that horizontal stretch is, or compression from inside the function there. So it's not necessary to do, but if you do see it written like that somewhere, that's what's happening. Okay, so now looking at more representations here, now we're going to go from transformations to try and create an image point. And what we saw when you're trying to create image points before, trying to figure out what's going to happen to this original point, that we need a mapping rule. So what we actually are doing here is going from transformations to mapping rules. And the nice thing about this is we know that the order of our transformations comes from the mapping rule. directly, so there's no need to take any inverse here, just to apply these transformations to the appropriate variable. Okay, so in this particular case, start by creating my xy here. When I'm reading these transformations, I need to ask myself, are these transformations affecting the x values, or are they affecting the y values? So first off, vertically stretched by a factor of 4. Well, if it's vertically stretching it, you know that's going to affect the y. So then we have a reflection in the y-axis. So reflection in the y-axis, this one can be a little bit tricky here. Remember, the y-axis is this one, the vertical axis, right? So if you're reflecting something across the y-axis, it's actually changing the x value of it. So even though it says y-axis in it, this reflection is affecting the x variable. Okay, then we're horizontally stretching it by a factor of 3. Well, horizontal stretch will affect the x. We have right 7, which affects the x, and then down 2, which affects the y. Okay, now that we've done that, we can start going through and building our mapping rule. So again, we just need to look at applying these transformations in the correct order to create the mapping rule. So let's start with y. So with y, we're vertically stretched by a factor of 4, so that's going to give me 4y. Okay, so that one's done. And then the next thing that happens to y is down 2, which means I'm going to subtract 2. So the y part of my mapping rule is just 4y minus 2. Okay, so for x, if I'm reflecting it across the y-axis, all that's doing is changing the x value from from one side of the y-axis to the other. So all it's going to do is flip the sign of whatever that x value is. So I'm going to go from having x, but reflecting across the y-axis is going to change the sign of it, so it's going to be negative x. So then I'm horizontally stretched by a factor of 3. So horizontal stretch, that means taking those x values, moving out further away. So I'm going to multiply those by 3, so it's negative x times 3, which is just negative 3x. Okay, and then right 7, well, if I'm going to move an x value to the right, it's going to add to it. So add 7 there. So what that does is give me my mapping rule. So now that I know my original point was negative 5, negative 18, I can simply do that substitution into the mapping rule and solve for my image point. Okay, so negative 3 times negative 5 is 15, plus 7 is 22. And 4 times negative 18 is negative 72, I believe, minus 2 should be negative 74. So you get 22, negative 74. Okay, so now what I'd like you guys to do is now try B on your own. So try and take the same approach that I did here. Try and see which of these transformations affects the x values, which ones affect the y, and then use the correct order, the order that they're written, to create the mapping rule to find your image point. Okay, so take a minute there to check your answer. So the transformations that affect the y values are this vertical compression by a factor of 0.5, a reflection in the x-axis. Remember, if you're reflecting something in the x-axis, you're moving it from, let's say, above the x-axis to below. It's going to change the y value. Okay, and we have an up 6. So vertical compression by a factor of 0.5 multiplies the y value by 0.5. The reflection in the x-axis changes the sign of it, so we get negative 0.5y, and then plus 6 for the up 6. So that takes care of these transformations. Now for x, we just have to be tricky about the order here. So we have left 4, so this x minus 4 has to happen first, and then we horizontally stretch it by a factor of 3. So the x minus 4, that whole thing gets multiplied by 3. Okay, so again, the order does matter. The order that's written should be the order in which the transformations occur. So then once you have that, you can put negative 5, negative 18 into the mapping rule, and you should get negative 27, 15. Okay, so we've done a lot of examples just dealing with functions that we just called f that could have referred to anything. Now we're going to look at some examples where we actually do know what our parent function could be. So I'm just going to get us started here. We're going to run out of time shortly before we finish this up in part 3. But what we're going to try and do in each of these cases is, before we create the mapping rules, identify a parent function. Because once we have a parent function, then we have some key points that we can use to then generate new points to then create a graph. So looking at this right here, when we're looking for a parent function, hopefully you recognize that because we have something here that's squared, that our original function, our parent function, was simply y equals x squared. Okay, and once you have that, you can then go ahead and start creating your mapping rule. Okay, so once you try creating it on your own, if you haven't really done a lot of mapping rules from actual functions before, I mean ones without f's in them, just based on actual parent functions you've seen. So try one first, and we'll go through this in part 3, and then we'll be on our way.